Although gravity has been around since the beginning of time, Isaac Newton was the first to discover the force of gravity in the late 1600s. Isaac Newton's Philosophiae naturalized Principia Mathematica in 1687. The mathematical principles of natural philosophy focused on force, mass, and motion, as well as introducing the universal force of gravity. In his definition of centripetal force, Newton states, "Of this sort is gravity, by which bodies tend to the center of the earth; magnetism, by which iron tends to the lodestone; and that force, whatever it is, by which the planets are perpetually drawn aside from the rectilinear motions, which otherwise they would pursue and made to revolve in curvilinear orbits." Newton explains the patterns of orbits caused by the force of gravity, but he did not know why mass caused the effects of the force of gravity. The origins of the force of gravity were not understood in the 1600s, as the idea that the Earth was not the center of the universe was a relatively new idea. 200 years later, Einstein would expand on Newton's laws of motion and the basic principles of modern physics that Newton developed. Einstein explains gravity in his general relativity theory as the warping of spacetime. He further describes the effects of the spacetime warping as a gravity well, where planets or moons continuously fall into orbits around other large masses. Both Einstein and Newton focused on the effects of the force of gravity that was caused by the mass of the objects. Since the mid-1900s, scientists around the world have been trying to identify and define the four fundamental forces in the Standard Model of Particle Physics at the European Council for Nuclear Research. There are four fundamental forces in the universe: the strong force, the weak force, the electromagnetic force, and the gravitational force. Gravity, the weakest of the four forces, thought by some scientists to be the elusive graviton particle, has not yet been found.